Welcome everybody to the 10th meetup of PHP at Milton Keynes. It's a bit of a milestone for us. Yeah, it is on. Okay. Thanks, Greg. Tonight we're delighted to welcome Greg, who's come all the way from Poland to give this talk for us. I'm not going to take up any more of your time. I'm going to hand straight over to him. So please welcome Greg.
Okay, hi. So the answer is no. Okay, so anybody that's not from workforce? You are. Okay, so I work at Intiv. I'm placed in Wrocław, let's say a small city in Poland, and I'm kind of a software architect, system analyst / anything where they need me guy. And I would like today to talk with you about JWT tokens and OAuth 2.0. Discuss how they work, what are the advantages of those, and how we managed to implement them in one of our projects, and of course the problems we have. So in general, we'll start with something that's so old that it's boring, cookie-based sessions. Then we will jump into explaining what the JWT token is. I'm suspecting many of you know this already. Then we will go into OAuth and some caveats of it and how the JWT token can be used together with OAuth. And then we'll start comparing where and when we can use tokens and how does this relate to cookie-based sessions. Then we'll go into the implementation in one of the projects, maybe not going into the code, but at least discussing the architecture and the solutions applied there. Okay, cookie-based session. So all of you probably know this, but a client, that's a browser and a person sitting in front of a computer, makes some request to a server for a web page, and this server issues something called session ID. The session ID is issued as a cookie, and it's meant to be hard to guess, and it's meant to identify this client throughout the requests within some period of time. In order for this ID to be useful, some data is stored on the server, the default implementation of PHP in files, and those files hold the IDs and the actual data that's accessible to us as developers, where we can store, for example, ID of the user, whether it's logged in or not, any custom settings we wish to be kept throughout the session. Now, the cookie-based session has some obvious features. First of all, it's kept server-side, what can cause problems. Both on the amount of sessions that have to be kept there and on the fact that maybe many servers wish to read it. It's very easily accessible throughout the session super global variable. And what's more, the PHP and actually the server cares about the fact that the session should be extended. If you are still on the page with each request, the session is kept active so that it does not suddenly expire in the middle of your session, of the time when you are viewing the page, and it's automatically cleared afterwards, so you don't need to care about junk things being left on the server. Because the ID is sent in a cookie, all modern browsers support additional security measures for this ID not to be easily stolen. So you can say a cookie is secure, that's a flag there, and then browser will not attempt to send it to any request that's not being secured by SSL. And if you decide for this cookie to be HTTP only, which you also should do, then JavaScript will not have access to it. Meaning the first flag protects you from the ID of the session being stolen by anyone in the middle who might be listening to the traffic. And the second flag protects you from XSS kinds of attacks, where malicious JavaScript code could steal this cookie and send it to the attacker. We know that if one gets the session ID from you, then he can impersonate as you. So for example, suddenly become an administrator. From the server's perspective, there will be no difference between me calling the same page with stolen session ID and an actual valid user calling the page with valid session ID. Okay, so session ID is simply a random value that's meant to be hard to guess, and measures have been taken to make it hard to guess. And the whole security of it is on the fact that it's hard to guess, so you cannot make it one on your own, and it should be as hard as possible to be stolen. But what if it simply weren't a random variable? If we could, for example, keep some data there and keep it in a manner that it's safe for us. And now we go into the idea of JWT tokens, or JSON Web Tokens, that are simply, let's say, some kind of a string. And they consist of three things. This is the actual representation of a token that can be seen in the requests. And this part and this part is simply base 64 encoded. And if you decode it, you will see a JSON for this and for this. Now, this is the header that holds the information about token being a JWT one, and the algorithm that we will talk about a bit later. And this is the payload. The payload is the place for your data. Some of the fields, like expiry date and issued at time, are predefined, but I think all of them, if not almost all of them, are optional. And you can place custom data here, for example, the name of the user, or whatever data you wish, and it will fit into the channel you are sending it through. And what makes JWT token interesting is actually the blue part, the signature. So the signature is simply a electronic signature that has been done on this and this. So you can see you encode those things, and then you sign it with some secret key, some encryption key. And once you signed it, it's very difficult to change anything inside without breaking the signature. It also tells you that the guy that created this knows the secret key, has the encryption key. In other words, you are able to tell this has not been modified, and a guy knowing this created it. If this secret, those secrets are asymmetric keys, so we have public and private encryption keys, then only one person holding the private key can create those tokens, and anyone knowing the public key, that's meant to be public, can verify whether they are proper. There's also another variant on JWT, so if you are worried about this, revealing this to the user, there's JWE format that says this is also encrypted. So you will be able to know it's valid, but without proper keys you won't be able to decode it. And now imagine that instead of a session ID you are just sending token. So client makes a call, server creates a token and sends it to the client, for example in a cookie. Now all the data is kept on the client side, as if we had all the data of the session in a cookie. And once it's kept there, the server does not need to remember it. So there are no files on the server, meaning no limitations of the amount of sessions one can have. The downsides of this solution are that it has some expiry date, and it's not trivial to extend it. the server has to reissue a new token before it expires. Okay, so the main selling point, this is usually when you see yay JWT are cool page, will be there's place for your custom data, for example user ID, no need to store it on the server side, no need to do any hard drive or DB call to read from the session data. So your API or whatever is the backend can be quicker, and basically anyone with a public key can check whether it's valid or not. So it cannot be played around. Okay, so for example, moving session to the client would look like this. Client makes some call, server instead of issuing a session ID issues JWT token that holds in the payload some value. If the client wishes to change this value or it changes for some reason, let's say to 2, then this token is reissued with a new value and a new signature. One problem with this is when a client makes a few concurrent requests, then this result might not be deterministic. Meaning, for example, if I increment it, if I say increment this value and again increment this value, then probably I will end up with value 2 and not 3. Now OAuth 2.0. Who knows it? Apart from knowing the name, who has used it? Really? Okay. So let's skip this part. No, let's go into details here because this is the interesting part. So OAuth 2.0 is known for only one part of it because it's actually bigger than many people think it is. It's the so-called authorization grant flow that we see here. What's the main advantage of OAuth 2.0? Why to use it? Mm-hmm. 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 Yeah, that's one of the usages. I would say something similar, but not exactly the same. You can allow any external application, let's say some Chinese developer does an application, which is called client in OAuth 2 flow, you can allow this application to get resources of the user. So, I don't know, my naked Facebook photos, without revealing the password of this user. So we'll go into this flow into details, but what's crucial, this user can tell this guy can read my, I don't know, Facebook wall, and password is not provided to him, my password. So let's go into the details into this, let's say, most known flow. The first, and we'll immediately go into how it's implemented on the web. So first, let's say I'm as a user go into some website or open a mobile application, and what this application does, it probably has a sign-in button, or it even does this without any sign-in, just directly. It redirects me to the authorization server, let's say UI. And this UI of the authorization server will do a few things. And now we go into, let's say, standard stuff. I'm either already signed in here. In such case, I will see probably information, do you want to authorize this guy? I may not be signed in, then I will be asked to sign in and then asked to authorize this guy. And in the first situation, that's, let's say, most interesting, I'm already signed in and already told sometime before that this guy is authorized. In such case, in all of those cases, assuming I actually authorize this guy, this authorization server creates something called authorization grant. It's in here, and redirects me back to the application. In the third flow, you can see that first I'm redirected here. Assuming I'm signed in and already authorized, I'm directly redirected back. User won't even notice he has been redirected there, apart from thinking why it took so long. Once I have this authorization code, I will be able to use it to gain access to the resources. I mean, being the client application. One thing to note here, authorization code is known to the server, the resource owner, and the client, so all the three parties. It's used because, and this is, let's say, the major weakness of the authorization code, because we don't want all the three parties to know one thing. That's why it's very short term. Will expire after, let's say, 5 minutes, and use only once. So once I have this code, resource owner is no longer in play, I will ask for a token. An access token is known to the server and the client. It's not known to the user, so user on his own cannot use it. What's interesting here is the fact that I not only send this code that I've been sent, but I'm also sending who am I, my client ID, that's the login of the application itself, and client secret, that's the password of the application itself. And we'll see later that the secret is not always used. It means that this authorization server, when it provides access token, has not only authorized the user, but has also checked whether that's the actual client to the password, assuming the password wasn't stolen of the client. The password of the client wasn't stolen. Okay. And finally, once I have the token, I can call for my Facebook wall. So, hello, who's this guy? This guy's ID is this, and he's John. We can finally say, hi, John. What's OAuth good for? For the fact that all sign-in operations and provide me password operations happen here. Password is kept only here. So it allows you for any client or any subsystem to have the same login and password without actually knowing it. And it can authorize not only resource owners, so users, but also clients. The less known fact is that OAuth has many other flows. So authorization code flow is the one we just spoken about. So you get the authorization code, the client gets the authorization code, then you exchanges it to token. There's an implicit flow, and I shall immediately say don't use it, because they designed it to shorten this flow, omitting the authorization code phase. That makes the process simpler, but when the user also has access to access token, it's also much less safe. And current recommendations say don't use this flow. It has user credentials flow, surprisingly. That's just provide me username and password. It's a simple login. Client credentials flow, meaning there's no user here. I'm signing in as the application only, and I want some resources from you. This is, for example, useful in a case where I have some application that, let's say, wants to read 10 most popular public posts in Facebook. So here, Facebook user is not involved. I just sign in as me, as the application as the client, and get those 10 most popular posts. It's also useful for any before logging scenarios. Refresh token to flow, we'll speak about it later. JW viewer flow is some kind of additional security measure where the client secret is encoded on its own. So when those are not sent, for example, for a safe channel. Okay, so for example, the user credentials flow is something trivial. You see sign-in form here. I provide username and password. You send it here together with my I'm this application things, and you get the access token. So it's a typical sign-in scenario, just there's client things here. The downside of this flow is that client now has seen the password. It's useful for native applications. Like for example, Facebook native mobile application uses this flow, Twitter native mobile application uses this flow. Where you fire up the Facebook application for the first time and you don't see redirection, you just see the login form. Okay, the tricky bit with OAuth that many developers have issues with is the fact that until you have access token, you know absolutely nothing about your user. And you have to be prepared for a scenario where your user is not yet in the system, and you have to register him ad hoc. If it's, for example, a closed system, let's say scheduling for the workforce people, then you need to know whether he's a, I don't know, staff member, manager, administrator, whatever. So usually you need those client-only credentials to first create this user here and tell once this user logs in, he will be a staff member. So that there are additional use case, I wouldn't say use cases, just technical requirements that we need to cover to have this single sign-on properly done. Implementation. So we were implementing based on this, but it apparently not supported from 1 year. So I will show the other one that I like less, but it still provides a ready implementation for the server. Almost ready implementation for the server. To install it, you just go into Composer. To set it up, let's say we want the authorization code grant. It's the most famous one. So we need to tell the data is kept here. Then you tell enable authorization grant on the server, set some configurations value that are customizable. This one, for example, says refresh token should be valid for 1 month. And enable grant. Once you have the server set up, you just need the endpoints configured. So authorize, this one will actually provide you authorization grant, and finally exchange the authorization grant to access token. For the other flows, you just enable those here. So let's say most time-consuming bit is providing those repositories, but you can try finding already existing implementations on the net. So let's say if you are not trying to be very custom, you can set one in 1 day. At least Rob can. Okay, enough of code. The major problem that we have, how to extend the length of a session. For a session, trivial, it's done for us. Of a token, calling to OAuth, you need new access token. You cannot just like that extend it. The information for JWT tokens already in the token. For other types of tokens, it's usually associated with a token, but not, let's say, public. They say to do yet another token that's valid for much more longer, but not used on typical get me the data and I will read the data basis. And what clients needs to implement, he gets this authorization grant, then he's given back access token that we already spoken about and refresh token. And refresh token is not used for typical communication, but once it access token expires, client has to implement now provide me new access token from the refresh one, and he's given a new one. And this is, let's say, a big problem for the system because it makes client implementations much more difficult. Especially if you are, for example, if you were implementing for Facebook, it's very difficult to test this scenario. What this idea with refresh token is about is the fact it's not being sent here and meant to be therefore safer, but I have doubts about it. Because it's still sent once a while. Now, when we come to refresh tokens, this is how Facebook and Twitter do it. So Twitter does not expire tokens at all. They are valid indefinitely. Of course, they can invalidate them for any reason, but in theory, it's valid forever. And Facebook, when you sign in to Facebook, to their API, you get a short-term token that's valid for about an hour. And you can immediately afterwards exchange it to a long-term one that's valid for 60 days. Once you have the long-term one, you cannot extend it. So after 60 days, you have to ask your user once more for a new access token. So they didn't do it by the book. And the reason is because it's much simpler than the implementation of this refresh token in clients. In my opinion, but that's just, let's say, I'm suspecting this. Security concerns. So there are, although OAuth 2.0 specifies really a lot of what should be done, what should be responses, what should not, and those are, let's say, two Bibles to read, very difficult to read, but they contain all the details. They don't specify, for example, what should be the inside the token. It can be anything. Actually, it could be inside, there could be a session ID. They don't specify. They provide some hints on how to invalidate tokens, but don't specify it. And don't tell you when actually a refresh token can be used to provide a new access token, when not. Whether a new refresh token should be also issued with the new access token or not, etc., etc. There are lots of minor caveats that are not provided there. And first problem we immediately stomped on was the fact that session cookie, this part is, let's say, fine. Hacker tries to make on a token or to cookie on his own. For a session cookie, it's hard to guess, and let's say it's been proven safe for many years. For JWT token, it's difficult to create or modify due to the signature. The bigger problem is here. So session cookie is immediately in a session, and I know one of you implemented the flags recently. And token, well, by the book, it's sent in a header, and it means it's vulnerable to XSS. Meaning, if it's sent in a header, then means JavaScript has to be able to read it, and then add it to the request, and then send it. If JavaScript is able to read it, if I have any malicious XSS, it will be also able to read it and steal it. That's not cool. That's really not cool, and really hated this fact and had to do something about it. The problem is also the token refreshing logic if you are doing by what OAuth specifications say. But the bonus is cross-site request forgery protection is out of the box, because JavaScript already adds something to the header, the token, and you are safe against cross-site request forgery. But maybe, what if I were sending a token in a cookie instead? So you can have those flags you want to have. How to refresh tokens there then? It's impossible to do according to what OAuth says, because JavaScript would have to know when to send it or not. If JavaScript had access to refresh token, that's equally bad as having access to access token. So again, not cool. And if you are doing in a cookie, you still need to think about CSRF. Now, even OWASP, am I saying it correctly? Decided to write on it. It's for Java, but applies actually everywhere. So they say, store your token in session storage, so JavaScript accessible, send in a header, and add a fingerprint, a really fancy name for something, to prevent stealing of the token. What's a fingerprint? Fingerprint is, let's go there, a cookie. So fingerprint is a random string, let's make it bigger, a random string that will be generated during authentication phase and will be included into the token and sent to the client as a cookie, and with the flags. And a hash of the string will be in the token. So what does fingerprint do? You send that token in the header. In this token there's this hash of this string, and in the cookie there's this string. So actually the XSS protection is based on the fact that you still are able to steal the token, but it will be useless without this fingerprint, because server will be checking the fingerprint. And alternatively, OAuth allow you to do this. So send the token as a cookie, so not what OAuth says, and have your CSRF protection separately. Client secret. I think this is the major drawback of OAuth. Not of a token, but on OAuth. The problem with the secret is that your client is usually mobile or web. It's rarely, at least we other users don't see it often, a server. If it's a browser, then where can it store it? Either it has to be sent prior to it, then it can be stored in session storage or a local storage or cookies on variable in JavaScript, whatever. All those things are easily readable, meaning it's not protected at all. For mobile it's a bit better, but still you can decode the application and find out the secret. And OAuth says you should use the secret only if the client can protect it. But if you are not using the secret, you have no certainty that this client is what he claims to be. For example, does Twitter know that Twitter mobile application that has this flow with password, etc., is actually this application calling him? And in fact it seems there's no solution to this at all, because the only way to protecting browser totally impossible currently. Protecting mobile, it seems some solutions are being prepared, but they are based on the fact that the Android itself is not messed up by a hacker. So Android sends some signatures of the application. And actually there has been a breach in Twitter a few years ago where they issued rate limitations to their API, but their native mobile application was not limited to them. And they hacked it quite quickly by pretending they are native Twitter application because of this. This is not possible to protect. But if it's on the server side, then you are safe, because server can keep it somewhere privately. Normal users don't have access to it. There are approaches that say we'll make it safe. I've seen a few. For example, using a proxy. So your client sends to a proxy, and then this proxy adds the client's secret and then sends it to the actual destination. Problem with this, if it's a dump proxy, and I've seen such tutorials on the web, and it means I can send any, because there and it will add the secret for me. Another interesting solution, I don't want to call the company, find it yourself, is that they provide yet another mobile application that will send additional details on the site to ensure your application is actually the client you want. But the truth is, and you can read between the lines, that the safety of their additional application is based on obfuscation. Obfuscation? Obfuscation. So it means it's not safe. Token invalidation. So sign out, immediately cut access, and the interesting case of signing out on all devices. Session, just remove the session or restart it. For tokens, if you thought you can rely on the fact that the token has a signature, the expiry date is there, meaning you cannot immediately invalidate it. It will be valid as long as it's not expired, unless you actually return to session mechanism of checking against your database or your hard drive, whether it's has not been invalidated. So you are losing this let's say, gain. But if you keep your longer tokens quite short-lived and agree to, let's say, allow people access for a short time after they sign out, then okay. So summary of main selling points of JWT when used with OAuth 2.0, because there are other usages that might be fine. So custom data only if it doesn't change during this session. Imagine I have this token from the authorization server and I want to suddenly place some new data there. Impossible. I would have to go back to the authorization server, place me this new data and provide me a new token. So the user ID is a finder, but I don't know, some counter of visits is not. It's not. If you don't have server-side storage, you have no ability to invalidate tokens. And if you want to invalidate tokens or need to keep some additional data, and you usually need to keep some additional data, you still need this DB call to something session-like. Also, you have to implement session on your own, meaning how to extend it, how to invalidate it, etc. This is not trivial as calling one or two functions. In general, if I were to give you a recommendation what those two things are good for, I'm not saying don't use them with OAuth. This has major advantages, but in general, the places where those two are clearly good for are in these cases mentioned here. So when you don't know who will be the client applications in advance, you have to use the auth flow. When you want to have single sign-on, that's usable, at least at the sign-in phase. If you want to have multitude authentication flows, so only the clients, password flow, the token flow, etc. So, for example, when we were implementing it, when I was finishing this project, we were using like 5 of those flows. So major advantages just gained there, and there were just out of the box. We need a new flow, 5 lines of code, and it's there. JWT user ID is immediately available. This might seem not important in terms, I have a render me whole page application at once, so typical request, whole page comes back. But if you have an API and are asking for small bits of information, often this may actually save you from doing yet another call to the database. And they are very useful when you try to do one-time claims. So I allow you to do this once. Then they are useful because you don't have the problems with refreshing, you don't have the problems with database, etc. It's just short-lived. I'm allowing you, that's all. Use it once. Okay, let's jump into how we actually implemented it. So before we implemented it, this was our architecture. Of course, it was much more complex, but let's say we can sum it up in those 3 boxes. We had front-end service that was in PHP and was serving whole pages. And we had about 20 backend services, and one of those services was user service, which kept user emails and passwords. And for example, if a user wanted to sign in, he issued a call to front-end service contacted user service was saying fine or not fine. If it's fine, he was signed in and a session was kept. Then a business came to us and they said, we want a fully functional mobile application in 2 months. And well, at this point you can either leave or start cursing. But yes, there was a lot of cursing. And there was a lot of discussions. What's more funny, we weren't doing mobile. Some external company was doing mobile, and they already had them hired to start in 2 weeks. Eventually, we ended up having our API to do sign in 2 weeks, to do some first calls in 4 weeks, and it was, let's say, fully or close to being fully ready in like 3 months. While mobile application development, that according to initial plan that they promised they will deliver, was meant to be implemented in 1 month, and they spent 8 months implementing. Just to provide you some numbers, our API had about 120 endpoints, so it was quite a challenge. So we ended up with this. After a few months of development, we, let's say, reduced the role of the user service, introduced authentication service. That's actually the authorization service. It's a backend service, keeps passwords. We introduced API service instead of this shitty front-end service. Later we introduced upload service, not to push large files through this. We actually modified, because we already had it, I didn't show it on the first slide, real-time notification service that does a WebSocket connections. It's used for live notifications and chatting. And we changed all our front-end to Angular. This was, let's say, ready in 7 months. And native clients were finally prepared, and we are actually ready for external clients, but we didn't have any yet. When it comes to responsibilities and the tokens, etc., so clients have to make sign-in request, send the tokens, send the refresh tokens, etc., etc. All those services need to validate tokens, so check the signatures and whether they are expired or not. And the authentication service is the only one knowing they go through API service, but it's the only one storing passwords and able to issue a token. So security is based on the fact that all those check whether token is valid, and this is the only one knowing storing password. Now, how we implemented it. So we really hated the fact that you can do XSS, even though we had Angular and felt quite safe with XSS attacks. So we have decided to send both the access token and the refresh token in a cookie. And web client doesn't even know they exist. I mean, the JavaScript Angular-based application doesn't even know they exist under the hood. For mobile, we decided to send the token still in the headers. So there are 2 different flows here, and mobile has to care about token refresh. About token refresh a bit later. We also had an remember me option in the sign-in form. And there are issues with how long the cookies should be valid, because tokens are kept there against the token validity. And for example, the user chosen to log in without remember me, the cookie holding the access token was valid until the page was closed, so it's a 0 length cookie. The refresh token was valid also until the page is closed. If he chosen to do it with remember me, access token was still valid for the same amount of time, but refresh token was valid for 6 months. So what does it mean? It means when I close the browser, those tokens are forgotten, at least on the client side. If I choose to remember me, refresh token is still present on the client side, and when I go back to the application, it will send only the refresh token. Also, it may happen access token is no longer valid because I'm stuck on the page for a long time, but refresh token is still valid. So for mobile and for web, we ensured that our mobile clients can only send tokens via headers, and web can only send tokens via cookies. You cannot cross them. Just to be sure they are not used not the way we want it. And the issue was that all this, let's say, caveats of the implementation had to be have at least basic checks in all the externally accessible services. So our API and the upload service and the WebSocket service had to check the tokens on their own. Refreshing a token. So we wanted to keep the client, at least the web client, as simple as possible. So we decided that API will be issuing new access tokens when they expire. Because they are in the cookie, Angular doesn't have any access to them or knowledge about them, we will be doing it for Angular. So it will issue new access tokens, assuming refresh tokens are there, as long as it wishes, and client even doesn't know the cookies change under the hood. For mobile, they had to go through the whole refresh token flow. Okay. Another issue was invalidate tokens. So we are proposing to the business, well, let's invalidate refresh tokens because those are kept safely and can be removed, and this doesn't happen very often when you need to check a refresh token once every, I don't know, 50 calls. And we just will wait for the tokens to expire. Well, this wasn't enough for business. They wanted to make sure when I click this button, everything is gone. So we actually had to return to the problem that I mentioned to read something that holds the information about tokens. So on each call, API asks whether the token is valid to Redis database. It has read rights here. Similarly, RTNS service WebSockets asks when a connection is established, whether it's still valid. If it's not, then a few things can happen. An authentication service stores to this database. Why did we do this anti-pattern of sharing database between systems? For speed, because it was on every request. We didn't want this to go through authentication service and then Redis and back on every request. At least we minimized this pattern because we provided SDK, so ready library to use this database. So happy flows for the API service are, is the token still valid against Redis? If it's still there, then fine. Happy flows against when access token expires or is missing. So this is a situation, I'm still on the page, but token expired, and this one is the typical situation where I've left the page and I'm returning, but I used remember me option. Then API service sends this refresh token, tells refresh it, please. Authentication service checks whether it's valid, issues it here and sends it back. Now what we implemented is a valid tokens list. After some while, I think it would be better to do a blacklist. So just keeping the Redis the tokens that are no longer valid, have been invalidated, because then this list would be much smaller to keep. This one keeps everything that's valid, this one just keeps the things that were explicitly set as no longer being valid. Okay, we also provided these two libraries. One library but two implementations that does the basic stuff for the front-end services that have to do the stuff. Not to ensure those services, API service, upload service, and WebSocket service, don't call this Redis directly, I mean through their own code, but call it through a SDK. Now, another interesting thing that's maybe not typical, not known for PHP developer, I didn't know it and had to figure out it myself, is that if you start doing Angular application that's using PHP just on like an API, there's no first call, and you just call the server in an old web page-based application, I mean whole HTML is just returned, it immediately the server knows whether you are signed in or not, and just sends you the signed in page or the sign in page. When you are using Angular, it just downloads a static file that has an information where to call and what to do, and the code of the application itself. But it has no idea whether the user is signed in or not where it starts. It has to call some API. And based on this information, it has to decide whether to, let's say, show profile page because he's signed or sign in page because he's not signed. And we solved this. The first implementation was that this client starts and makes a call to one of the endpoints. That means will respond either you are not authorized or provide you the details the application would need anyways. The problem was that most of the entries or bots, etc., were entering the page, and this call was being made for useless reasons. So we added yet another cookie, simple flag, that we do not trust, but we act according to it, meaning if this cookie is there, then try to do this flow. If this flow fails, return to the sign-in. If the cookie is not there, immediately go to the sign-in, don't bother with this other flow. So this dramatically reduced the amount of calls to the API. Endnotes. So what we gained with OAuth 2.0. Many clients can access API, and we no longer cared who's using it. Only one place where we kept user information, and we are ready to keep it across any systems. Passwords kept only in one place. They were accessible through two services, API that's all the calls went through, and the authentication service. Assuming we will someday be able to know who's actually the client, we will be able to properly control the access scope of the client. But assuming a client is server backend application, we can provide him, let's say, more access than those clients, mobile and web clients. For example, to some administrators panel. With JWT tokens, so only one place can issue them, which is cool. We already have the user ID, and on the, let's say, less important calls, we are using it heavily. So we already knew, if I was asking on the API, give me my photos, we immediately knew for whom. Security, in my opinion, was similar to the cookie-based session. And also we could use the same tokens in the backend. Assuming the services don't trust each other in the backend, on an API, it can be also sending the token to saying on behalf of whom, so that it, for example, cannot send a request on behalf of random user. Problems, well, our own session implementation actually. So renewal and invalidation were pain in the ass. Also, we had to do some custom implementation with those cookies, not with the headers. So actually redirect how the data is sent to use them in the cookies. And you know, if you only need sign-on, single sign-on between applications, it's better to just use this flow, get the token, and then start using session. It will be simpler for you. If you need something more advanced, well, you are still ready because you have those components, but it's much simpler to just initialize a session once token is there. And if you only need single sign-on, always require all your clients, because here there's clients database that are server clients to provide you the secrets. So if you can protect the secret, always require it. Then you will, only then you will know that this is the client that you are using. Some boring links. I like this one because it has huge graph saying why JWT is useless for sessions. I don't know whether it's too small or anybody reads it. You will be able to see it later. Yeah. That's it. Questions? Go ahead.
Got talking to the mic. In this scenario, when you had a simple is the token valid versus refresh the token, what was the performance difference of each call? How big were we talking? Are we talking a few milliseconds, or was it quite significant?
You mean?
Yeah, it's like the lot. This guy here, yeah. What was between those two?
Frankly, I don't know. But I know that calling yet another service usually took, let's say, 5 to 10 milliseconds. But that's not good, let's say. I don't know what can you gain from this information, because under the hood there's something more complex under this line at our system. We weren't using HTTP here.
It was really just a point of curiosity. When you're checking is this token still valid there and you're storing it in Redis, are you putting the tokens in Redis and the keys expire in Redis, you're programming in the key expiry, or are you actually pulling it back and checking it?
So when this guy stores it here, it's with a TTL that's equal to how long the token is valid.
Yep.
When you sign out, this one removes this here and this here.
Yep.
Sign out on all devices, that's interesting. It removes all associated to user ID number X here and all here, and meaning no client and no our API no longer can use it. This one is Mongo, and the brutal truth is we weren't cleaning those yet, but we are storing backlog. But refresh tokens, let's say there were not so many of them.
And then one last one, which I was curious about this. I can understand not storing these in the same instance, the same copy of Redis, the refresh and the access tokens. But why use two different data stores for this? Why not just simplify the stack and just have another copy of Redis storing the tokens, the refresh tokens, sorry?
Because the Redis, if you are not using a cluster, can die. If it's only memory-based database that needs to use this information. Our system was actually prepared for this scenario, but and refresh tokens are 6 months lasting, so we would be losing them, and we
So
preferred something more secure in terms of keeping the data.
Cool.
Any more questions for Greg? In which case, I think hands together, because that was really, really interesting. I certainly found that.
Okay, thanks. So if you want to spam me, you can.
I'll send out the way the instructions.
Yeah.
I'll send around all these slides afterwards if people are interested.
Yeah,
and yeah, thank you very much, Greg. That was really interesting and a great introduction into JWT and OAuth, especially. I thought the business requirements was quite funny when they just threw the 2 months on you.
That's the business.
I think everybody's been there at some point before. Pizza is about to turn up. Apart from that, I think that's the end of the talk for this evening. But just feel free to stay and have a drink.
I think you prepared one.
No, we couldn't find you initially. I thought you'd run off, in which case I was going to have to try and improv something around your slides, which I think everybody's sort of quite grateful they didn't hear that. But thank you very much, Greg.
Thanks.